Hi Yusuf, it's asking me for a email ID and password.
Yeah, so you might have created a user ID password yesterday.
No, not in Citrix.
So you directly logged into it.
Yeah, I directly logged into it.
Yeah, so with the same link now, you can again log in directly.
But you said that I'll have to initiate, so it says start the meeting. It says if you're the organizer, start the meeting.
Yeah. Okay, give me 2 minutes. I'm also logging into it.
Haha.
Let's see if we can come up with it. Yeah.
Not a problem, not a problem.
Just give me 2 minutes.
Sure.
Welcome to the webinar. Please stand by. The webinar will begin shortly. Please remain on the line.
Yeah, Yusuf, I'm logged in.
Yeah. You logged in, but you logged in as an attendee. You might be, you've taken the link which I sent on WhatsApp, right?
No, on the email.
Remain on the line.
Yeah, on your Gmail. Open that link.
I opened the Gmail wala link.
Okay, let me see. I'll do it from here. Yeah.
I opened the
Now
Gmail.
you're the organizer. Now I'll put you as the organizer.
Okay, okay. Fine. One second.
Presenter. Yes.
Okay.
Yeah. Now your screen will be visible to everyone once you start broadcast.
Start broadcast. Okay, I've done that.
Yeah. So you're on the Citrix page connected to go to webinar.
You can see it, is it?
Live now. Live now. There are another 6 people also. So it's like checking your phone headphones working. Yeah.
Can you see the page?
Yeah, I can see your screen now. It's on the Google sites of Google.
Perfect.
So can we talk on the webinar?
I'll do that. Thanks a lot. Yusuf, can you hear me? Yusuf, can you hear me? When I speak, I can see this audio thing going up, so it seems I am audible. Somebody needs to confirm because I'm new at this. I'm not very sure how this works. Kunshal, can you hear me if you're there? Yeah, Yusuf.
Hello.
Yeah.
Yeah, Rohit, we all can hear you. I think there's some problem with my mic, so it's not audible to you, but we all can hear
So I can start off?
Yeah, you can start off. Yes.
Okay. Can somebody give me an indication in the chat at least?
I'll put it in the chat window or maybe on the WhatsApp. Yeah.
Okay, so as long as everybody can hear me, it's okay. I'm fine with that. Okay, I'll start off with the session now. So on this page, I had basically referred 2-3 books over there. So one is this online statistics education book, and I'll keep on speaking. So in case anybody wants to interrupt me or anything you want to state, please put it in the chat. The recording is already started, so I'll share the. I'm sure Yusuf can access this later on, and we put it up on the channel that we are planning to create. And okay, so one is this book which is there, which is right here. Online statistics education, and the other one was the R in action. So these are both free books, and what I had requested was that in case it is possible, please go ahead and read about first 35-36 pages of this. So let me just show you as to what exactly is there on the first 36 pages. And before I even go to that, can you please go ahead and share as to what is your expectation from these sessions? If you can just go ahead and maybe type a few words, a few lines maybe, and let's spend some time to try and understand that. Because I got some inputs from Veda and we've gone ahead and we started off with this. So before I jump into R or I get into any of the statistical things, I just want to understand as to what is it that you would want to kind of learn through these sessions. Absolutely anybody, please go ahead, take the lead. Can you respond in the chat? Can somebody respond in the chat just so that I know it works? I'm not sure if you can respond on the chat. Yeah, so Yusuf is saying everybody is able to hear me. Okay, so do you want to respond to that question, Yusuf, or somebody else, or should I just go ahead in a monologue? Okay, who all do I see in attendees over here? Kunjal is there, Murli, Krishan, Riyaz.
Rohit, can you hear me?
Yeah, Yusuf, I can hear you.
Yeah, okay. Well, Murli has asked this question that his expectation on ML on predictive analytics. So I'll just copy that for you.
No, which is okay. So ML and predictive analytics, is it?
Yeah, my expectation on ML on predictive analysis.
Okay, by ML, I hope he means machine learning, because besides that, I'm not sure what would be ML.
Yes, he means by the same thing. He said.
Right, Murli. So if you know machine learning, so machine learning is it's a little bit far away for us right now. So what I'll do is I'll start off with the introductory session today, and let's see when we can reach machine learning. Because I myself am quite new to machine learning. I'm not an expert over there, so I wouldn't. So anyways, let's see how this goes and how long we can stick along together on this. But I'm sure machine learning is not something which is very tough to learn, or something which is out of our reach. So we'll do that very soon. I'm pretty much sure we'll do that. Okay, so in case all of you can see what is on the introduction page of this book, it says what are statistics, importance of statistics, descriptive stats, inferential stats. These are very basic things over here. So in case all of you are already okay with this, I I'm not reading from this book. I would want to get into descriptive stats and inferential stats. So descriptive is basically you have some data inputs with you, and you want to go ahead and uh, describe them in a more understandable manner. So basic graphs, bar plots, whatever kind of charts that you have, all kinds of charts, tables. So that is basically descriptive statistics. So it is you are not inferencing anything, you are not really predicting anything. And inferential statistics is basically where you go ahead and you start drawing the inferences from whatever inputs that you have. Next is variable. So what exactly is a variable? A variable in a statistical language or mathematical language, and keeping the description very basic, is something which can take varied values basically. So variables will be of various types, and they can take varied values. So let's say we create a variable x, and we go ahead and say, okay, before I even go ahead, has everybody been able to download RStudio? Have you been able to do that?
Yes, that Murli says yes. Riaz also says yes. Sirisha says yes.
Okay, perfect. So, and you've gone ahead and launched it, or you're already familiar with RStudio, or should I help you do something over there? Okay, Riaz, what you're saying is I expect to get an introduction to R and a better understanding of its pros and cons. I will not say use R before other programs. So in case you've used SPSS, or you've used Excel for analytics, those are additionally much more interesting probably. I don't know, I can't say. But if you really want to be an analytics person, whether HR analytics or absolutely anything else in business analytics or things to that effect, you really need to be comfortable with R. That is one requirement which is there. Interest in how easy it is to import data, manipulate the structure of data modeling, and basic visualization. Okay, yeah, it is easy to import data. Importing of data is extremely easy. You can manipulate it also pretty much well. Data modeling can be done. Visualization, not only basic but advanced visualization can be done, and there's a lot of packages which are available for that. So reference book download URL. Murli, we had put it in the invite also. It is here, it's on this particular page. So all of these are the reference books. R in Action, R in a Nutshell, second edition. So this is on that page that I have created for this webinar. So these are the books which are there. And these are freely available over here on this particular site. It is IT ebooks. What I'll do is I'll paste it over here in the chat. So now you have it. Okay, so this is basically a little background into, answering whatever questions that you had. Now, if you already have R installed, can you please open up this other book also, which is R in Action? And if you can open this particular book and go to page 120 straight away. So what I'll do is I'll straight away jump into this, and from there onwards, in case anybody's got any doubts or any questions, so we'll address that during the session, or we will go ahead and execute code straight away from this particular book. So we will go ahead and execute code from this book, which is freely available to all of us, so that we are on the same page. And then okay, Yusuf is saying everybody is not familiar. So can you at least confirm that everybody has got RStudio installed and the application is launched? So does it show you something like this? Is there a screen which is something like this? Okay, so RStudio is installed and it is launched. Perfect. So I'm taking that as a confirmation for everyone. In case somebody still got a challenge, please let me know. Otherwise, I'll start off with this then. Okay, to do a quick. Okay, perfect. So I'll just still do a quick tour of what I have over here. So I've got an older version of RStudio and R. I don't have the latest this thing. And what I have here is basically a script window. So can you all go ahead and create a script window on your own, or see, the simplest way of doing this is you go over here, it says R script, you click on that, it creates an untitled script, and then you start writing this code which is here. And this code I'm putting it in the chat. And the chat can pop out, so it should not be difficult for you to copy this. So if you're able to open up a new script, which will be opened from here, it says R script. And if you can copy this code, whatever it is that I have right now, in that particular window. So what I'll do is, I'll keep copying code from this particular book, which is R in action. And I'll quickly keep on explaining as to what is happening in the background and why we should be doing this, or what a particular function means, or how to seek help and things to that effect, so that we can cover up faster in place of me getting into creating own functions or doing all of that right now. And once we've done this, and once we are okay with that, and all of us are comfortable and we say okay fine, we can go ahead, then we can get into examples of machine learning. We can straight away get into that. I have absolutely no problem doing that, but I want to make sure that everybody is along with me. You understand as to what is happening, because I'm not sure. I think Veda is not here on the session. From what he had initially communicated to me, I thought we would want this to be a very, very initial session, which is probably not the requirement, which is perfectly fine. So can you confirm that the R script is there and you are okay with this? Yusuf, in case anybody is texting you, can you please confirm? Are we okay with this approach, or do you want me to do something else? Can you please confirm that also? Because I don't want to end up wasting your time. So in case you are not okay with this approach, we can try whatever it is that you want. Now, why I picked up R in action is because that's the first edition that I am referring to. That's the most basic book which is available for learning R. And once you've learned as to what is happening in R, because this obviously this book does not get into machine learning or things to that effect. It stops somewhere with linear regression, which is again very basic statistics. Perfect. So the script is there, so we can continue. Perfect. Excellent. So is everybody aware as to how we go ahead and access packages, and what exactly are packages within R? So let me explain, presuming that you are not aware. In case you are aware, just bear with me. So when you go to RStudio and you click over here, it says packages. And you see a list of packages. So this is the name, there's a description, there is a version as to which particular package is which version is uploaded, and most of these are from CRAN. Now CRAN is the repository for R. So let me go and show you as to what CRAN is. And this CRAN should be your Bible for learning R. So whatever it is that you want to do, besides whatever you can find on the internet, CRAN is supposed to be the Bible for everything, and it's the main repository. And you would have gone ahead to download R and other things. Okay, so another very important thing over here is the packages. And this gives you a list of all the packages which are there in R. And now you got that same list over here. So in case you want to install something new, all you need to do, especially with RStudio, is you go ahead and click on this particular icon which says install. It will come up with something. So it will say, okay, fine, where do you want to install from? Usually CRAN is what you want to do. In place of, or maybe somebody's got some package in one particular location or something to that effect, then it's a different story. Let me say I want to go and install ggplot. It will give me the option for ggplot2, because ggplot, the initial package, is probably not there anymore. And if I say install, so that's just just showing you as to how this entire thing works. And this is basically my console area, this one, the one which I'm trying to highlight now. And within that it will say installing packages in C, user, Rohit, documents, whatever. It is giving that particular location. And it's installed ggplot2. So even if I had ggplot2 installed earlier, what it has done now is it's gone ahead and updated that. So the latest version of ggplot2 has got installed on my system. Now similarly, what we want to do is, and when we access these packages, when we want to load any of these packages in our system, while we want to utilize this particular package, what we need to do is we need to go ahead and say library and specify that package's name. So let's say I have got VCD already over here. I go ahead and say library ggplot2. So it will show me, okay, library ggplot2, and for some few moments there will be a red this thing over here, icon over here, which will show that this particular thing is loading. So I hope everybody is okay, or you want me to speed up things. Are you okay with my pace and what I'm trying to do? Just give me a confirmation, please. Yusuf, things are okay?
Just checking.
Yeah. So let's say we've gone ahead and installed this particular package VCD. I did not have this earlier, so I've just installed it today. And I've gone ahead and said library VCD, so it's gone up here. Another way of going and choosing a package is by, okay, say I go and choose A rules. A rules is basically association rules, and in my console it will show library A rules something lib something whatever. So this particular thing I should ideally go and copy into my script, because once I do that and then I want to run this script on my particular machine again, so this is the best way of launching A rules. In place of just saying library A rules, this is the preferred manner. Now I can't necessarily say why, but once I do this, I do not get any errors, and especially when I'm creating markdown documents and publishing directly from RStudio onto the internet by using RPubs. So it does not necessarily give me errors. Otherwise, sometimes just saying library gives me errors. Okay. Now this package VCD has basically got some functions inside it. It has got some data sets which are there available within it. And if we go ahead and we look at R in action, and it says over here on page 120 that go ahead and use the arthritis dataset. Okay, so I just highlighted that. It says install package VCD. So if you already done that, great. Otherwise, on the command line also you can go ahead and say install packages VCD, so that will get done. Now this is the page I want you to refer to. Any which way, that code I have given you. So data arthritis. So it shows over here arthritis promise. So basically promise means that's a particular class that they're going forward R understands that this particular data set would be either loaded or required, or some actions would happen on this particular data set. And then we say attach. Now that's a good practice to do. You go ahead and attach the data set, whichever data set it is that you're using, and then you go ahead and look at what exactly is in there. So if you look at the summary, it will show you that there are 1, 2, 3, 4, 5 variables over there. The first one is ID. The ID starts from a minimum value of 1 and goes to a maximum value of 84. The median, that is the median of these values 1 to 84 is this. The mean is this, the first quartile, the third quartile, and presume we were processing something on the ID and we were doing some calculations or something. So this kind of a summary output would help us, but we are not doing anything on the ID, so we can just skip this. And then the treatment type. So there are two kinds of this. So it's a let's say it's a binomial variable, or it's a factor variable, and it says 43 are placebo and 41 are treated. So which means out of whoever is here, whatever patients or are suffering from arthritis, 41 actually got a treatment and 43 got a placebo. Yusuf, everything okay? I'll keep on continuing till you put something in the chat, or you give me a ring, or whichever way. Okay. And next, of course, so next, of course, the the classification basis sex. So how many are males, how many are females over there, and then the age. So minimum age is 23, maximum is 74. So the first quartile is around 46. So you see that the spread is more towards people above 46. So within the first quartile itself, whoever falls between 23 and 46. So we don't necessarily know how many people are there within this particular range, but that gets covered within the first quartile. And so mostly everybody is above 46 years, which is okay, arthritis usually. And then the status, the condition, has it improved, has it not improved? To some extent it has improved, to a great extent or a marked extent. So all that summary of that data set would be there. And presume you actually wanted to understand what exactly is this data set. So just put a question mark right in front of it. So that question mark means help. So for getting help within R, you do that. So you go ahead and click arthritis. So over here, where I was showing you packages, the help window pops up, and you get to see that arthritis is within package VCD. It's arthritis treatment data, and you can enlarge this further by kind of expand it further. It gives you a description. It tells you how to use it. So this is the usage. And let me do another thing which I have not done earlier. Let me go ahead and copy this. Copy this and paste here, and let me say class. So it is showing us that arthritis over here is basically a data frame. It shows me in the console that arthritis is a data frame. So fine, so we are okay with the summary we've seen. So dimensions. So the dimensions of arthritis, there are 84 observations or 84 rows. So the first one which is shown is, and let's say we were to say dimension arthritis, and or is it one? I think one. Okay. So it is showing us that within the dimensions of arthritis, what is the first value? And similarly, if I were to go and do 2 over here, it will only show me 5. So that's how you can extract data from R, where it stores something in some particular manner. So you can go ahead and extract that. And Okay, now we want to view arthritis. So there are two ways that we can view a data frame or a, even a matrix which is there. I see only 7 attendees are there now. So are we okay, or are people leaving? What is happening? I'm not sure. Okay. I'll still continue with this. Yusuf, should I continue? Should I stop? Murli, what should I do? I hope you guys are okay. I'm not sure what this is. Which is not attentive. Okay, fine. So Murli is attentive. Okay, fine. So whichever way. Now, so this is how to basically view arthritis. So if you want to view that data set, you can view it over here. It shows you the IDs. It shows you that next variable, the sex, the age, the improved, not improved, all that status, what we could see earlier in the summary. And another way of viewing the data set is that you go ahead and click on this matrix over here. So again, it pops up, you can view it. Okay, now let's do this. What we'll do is we'll create a table out of this and look at within arthritis the variable improved, and create a table which we will store in something called counts. Now what exactly is counts? What you can do is you can come over here and you can see that counts is a table. So if you yeah, which is okay, Yusuf, that is absolutely okay. That not attentive is not my concern. My concern is why 3 people have dropped. So in case they didn't like the session, so we need to do something different. Okay. So what you can also do is you can have class over here and look at counts, and it says the class of counts is a table. So in case you want to find out what kind of class you are dealing with, then this is a way of looking at it. Otherwise you can come here and put your mouse on this particular thing which says counts. It will show you it's a table. Whatever bytes we can leave that for later. So now looking at the simplest plot, creating a bar plot, and because the plots will pop up over here, let me enlarge this a little. That is the best thing to do in R, because R is very memory hungry. So sometimes what will happen is if this window is minimized, then the plots will not come up. It will give you some kind of error, and you don't necessarily want to get into that. So let me first create the plot, and let me then explain as to what all is there. So this is what the plot looks like. You can go ahead and zoom. It pops up in this particular manner. Not very fancy to look at. Nothing very smart. So what we'll do is we'll create some smart plots also. We'll do that later. And you can export this. So in case I wanted to save this, I say save as PDF. And you can use whatever size you want. Let's say we use A4, portrait, landscape, whatever. And we say plot 1. Let's just call it plot 1. And let's save it. So it pops up on my screen in a PDF, and that's how simple it is to create a plot in a PDF document, and this will go ahead and get saved over here. So this is where this plot has got saved. It shows it's a 5 KB plot. There it is. So that's how simple it is. Okay. So going back to okay. Now within this bar plot, firstly is what is it that it's creating a plot of. So it is basically creating a plot out of that table class which is counts that we created over here in line 13. Then main means what? Main means so main basically means that you've gone ahead and created a particular plot and you are naming it. So over here it says no jargon now, and earlier it was not there. So you're just going ahead and naming it. Then what do you want on the X label, X-axis label, what is it that you want? Y-axis label, what is it that you want? So improvement again, let's just for the sake of it, so that we know that this really works. It's very basic things that we are doing here, but still. So again, so this labels have got updated, right? So yeah, it says improvement and frequency, no jargon. Okay. Now done with this, we go back to the no, not this one. Okay, so this is basically the bar plot and the horizontal bar plot. So nothing very fancy. I am just copying code from here. I am putting it here and I am running it. So how am I running this code? I am selecting this entire piece and I am saying run. Now I've got this bar plot over here, exactly like what you see in the book. In case it doesn't work out or there is some challenge, then you probably need to look into it as to why it is happening this way. Otherwise, usually the code executes. So what I'll do is, I'll again, within the same book, I'll go to something which is slightly much more fancier, and so this is just plotting, changing color, nothing very difficult to explain. Again, we'll just leave all of this. Yeah, I think this is what we want to do now. Okay. I'm copying this entire chunk of code over here. I'm going back here and I'm saying first empty cars. So what exactly is empty cars? So empty cars again is a data set which is there, which is motor, trend, car, road tests, whatever, and it's got with 32 observations on 11 variables. So like earlier what we had about 84 rows or something that I remember. Now it is 32 observations or 32 rows with 11 variables being 11 columns. So that's what the data set is. Now again, the good practice, we attach empty cars and we say we view empty cars, and let me copy empty cars. I probably keep on doing that. So this is what it looks like, this particular data set. So it shows row names which have got names of the cars: Mazda, Datsun, Duster, 360, whatever. So the miles per gallon, the cylinder capacity, sorry, the number of cylinders, the displacement, and other things are there. So if you want a description of what all is there, you can go here, or you can go. So since 1981, this particular data set is available to people. So it says here 1981. Okay. So we've done this. Now copying that code again. Okay. So what does this mean? What does this par mf row is equal to C, this thing? So this will basically go ahead and create multiple plots within, or multiple graphs within that particular screen, or within that particular PDF document also. So you can export it as PDF, you can export it as PNG, you can export it as JPEG, whichever way you want, you can go ahead and export it. So this will go ahead and create that basically that space within R that will go and say, okay, fine, this is what I want to do. So it's allocating memory, and it is telling R which way to go ahead and plot, once we plot, that is. Okay, and this could even come down here, you know, this piece of code can come down here, let's say. So we don't execute it up there, we execute it down there. So what is happening is, we are going ahead and choosing density from miles per gallons within that. So within that data set, empty cars, which we saw over here, how to go ahead and access this particular variable, or how to go ahead and access this particular column. That can be done by putting this $sign. So empty cars is the data set that we have, and by putting this $sign, we can go ahead and access that particular observations within that particular variable, or within that particular feature. Now we want to plot this D. So have we created D? One second. Yeah, so D got created. What exactly is D? D is a list of 7. Now, in case you want to understand what exactly a list is, again, question and list. So generate dotted pairs, functions to construct coerce and check for both kinds of R lists. Again, within R in action, in this particular book, all you need to do is search for list, and it will give you a description. List is slightly different from a vector, different from a matrix or a data frame. List can have different kinds of variables within it. So that is one difference that I can remember. Rest you can look it up. So it's a pretty simple thing. And now we say plot D. So this is how it got plotted. So this is the density function. Density function of those particular variables. Now comes the question, what exactly is the density, and how would you differentiate between something like say density or simple cumulative density and things to this effect? How would you do that? So for that, this particular book will come in use. So if I go ahead and do density over here, I search for density to begin with, probability densities. Right, so this we need to go through and we need to understand. So you see a normal distribution over here. What you see over here is not a normal distribution. If it were to be a normal distribution, it would be like a bell curve, but it is not. So for this particular data set, we do not get the probability densities in this particular manner. And again, if I were to just go ahead and do density here in R, density estimates, kernel density. So kernel we can skip for now. It's density estimates does so with the given kernel bandwidth of a univariate observation. So univariate observations are basically observations from a particular variable. Multivariate observations would be observations from multiple variables, more than one variable. And to plot densities from multivariate observations, you wouldn't get one line only. You would probably get more than one line on that particular plot, giving you densities of those different variables. Again, you have to refer to this particular book or any other book which is available online for that, because we don't necessarily have time to be able to explain that, and that probably I'll have to prepare separately for that, which I have not done. Okay, so now the next thing we are looking at is this particular structure. So this particular structure says that we want two plots together and one plot separately. So if you look at this, what is the plot which is being created down here? Well, let's create this plot ourselves and then let's look at it, how it gets plotted. Whether we can get those colors like they are getting, is it happening, is it not happening, why is it not happening? Okay, so over here nothing has happened. He's just gone ahead and given main and the name to that particular plot what we had earlier. And this is how the coloring of that particular thing has happened. So again, nothing fancy. But what I'm not getting is why did they put par over here and that has not been executed, because par usually means that you would plot them together. Okay, so by moving par down here, I've actually spoiled the code. What I'll do is I will go ahead and comment this and run this entire code together, and this is what we get. So within that one particular frame, we get to see these two different plots. On top is the default name, which is density.default x is equal to empty cars $mpg, and down here we have kernel density of miles per gallon, which we have changed. So these two get plotted together in the same frame, let's say, and once we export them to PDF, we get to see both of them in the same PDF document over here, which was not the case earlier. Earlier we just got one plot, which was the bar plot. So this particular line of code over here ensures that we get two plots within the same frame or within the same PDF document. Okay. Let this save. Now, having gone through this, I think we don't have much time left for the introduction, and this is okay. So next session probably we can get into other things. I would now want to get into this other big data crunching piece that I wanted to show everyone, and let's see how that can be done. Okay. Now here is a script which I have written earlier, and so install RStudio and all of this has already happened, so I'll just skip with this. So this is library rcurl. So rcurl is basically required for getting in, and I'm just going to, by clicking on this red thing over here, I'll remove all these plots. So these plots will get removed. Sorry, clear all. By clearing all, I'll remove all these plots, and I will also clear this. So this will clear the environment. So whatever is there in my workspace, this arthritis, this count, this D, everything goes away. We don't need this anymore. Yeah, and I close this particular script. Before I close this particular script, let me see if it allows me to create. Let me see if I can create a web page out of this. It's still working. So when you have this little red dot visible, so yeah, because those data sets we had referred to, they have come up over here, and which is okay. Yeah, this is the output. So this is basically what we had done. Right, so I don't want to publish it. If I were to click publish, it will straight away publish to the internet and publicly visible and all that. I don't want that to happen right now. If I want to open it in my browser, I can do that. It will open up in Google Chrome and any other browser, I presume. So here it is. Okay, so we'll just let this be for now, and probably because we'll want to post this code later, so we can just go ahead and create a PDF out of this. Yeah, so it says processing file webinar. So when it says processing file, things are okay, but sometimes larger things can give you a challenge. So like we'll see in that big data piece, it might just give us a challenge. We can't necessarily be sure. Okay. So this is the document that I get, and I can save this over here. So I just go ahead and save it here. Webinar 1 R code, okay. And I just let that be. And I close this particular script. I come here, R curl. So library R curl is basically to import data from a particular URL on the internet. Prior is for some memory purposes. So I've already gone ahead and downloaded these packages. Yusuf, can you confirm everything okay? What exactly this question, this thing? Okay, well, I can see the questions here. I was not sure if I could. Yeah, guys, so in case everything is okay, I'll continue. I'm sorry, I was not aware of this. I'm new to this webinar application. Okay. So I'm continuing with this. Now, file matrix is again something which is, I've just downloaded. I've not been able to play around with file matrix yet, so I can't necessarily say what will happen. And this hash over here is basically to designate a comment. So I'll remove this particular hash because I don't need it now, and I want to actually go ahead and import this data set into R. Now things could get a little crazy because depending on how much memory is being used by my system right now, which let me check. So how much memories are using and how much memory I have. If I will just go ahead and check this, and I've got some benchmarks for earlier. Yeah, so right now things are okay. It shows that this much is my total memory size, which is 3 GB. I've got 3 GB RAM on my system, and this is what is being used. So memory currently in use by R. So it clearly says over here amount currently used by R. So this what I'm doing is just for your reference later on. I'm sharing this with you in the chat so that you can compare. And if my system crashes and everything, becomes extremely bad over here, so you at least know as to why we got into trouble. Okay, so let's start with the big data one. And okay, so this is the file that I want to import, and it's a freely available data set on 1 second, what happened here? Yeah, so it's a freely available data set on the internet, and here you can see it says URL file something whatever. So basically I've just gone ahead and stored that URL location into this. I have not gone ahead and downloaded it yet. Now I'm getting that URL, so it says get URL, and then I will go ahead and import that URL into this particular object that I'm creating X, and let's see what X gets created as. Okay, now you can see this red little thing over here. This is actual download from internet is happening right now, so it might take time depending on my speed of download and memory usage and all that. It might just take time. So till then I'll use this time to remove these other commented hashes that I have over here, because I now want to use this code. Okay, so it took I think around 10-15 seconds to download, which is perfect. So it says a large character 64.6 MB. So okay, 64.6 MB of data has been downloaded, which is okay. Now what we want to do next is we want to create BD underscore raw. So what is basically happening is we are creating a table which we are calling BD underscore raw, and from where are we doing this? We are doing this from a text connection. So what we got earlier over here, this X is, it says a large character. So there is some class which is there, which is a character class, and it's a text connection, and it is not necessarily you can't necessarily view it in columns and rows as such. But now what we have created, this BD raw, is basically a data frame. Now this particular data frame is I think there are some questions again. Okay, Riaz, you're most welcome. You've left. How do I put this back in? Okay. Yeah, so this particular data frame we've gone ahead and we've created. And this data frame is now extremely large data frame, so we can call it big data if we want. It has got 6,000 observations and 5,000 variables. So 5,000 variables means it's got 5,000 columns, and 6,000 observations means it's got 6,000 rows. So this is pretty okay for a laptop to kind of manage. So what we'll do is we'll get my working directory. So get WD basically means you get your working directory as to in what directory you are working as of now currently, in which particular directory you've loaded your R and you're doing your project and everything to that effect. Okay, fine. So get working directory and a write table. Now if you see, my working directory is within my C directory. I am in webinar underscore 1. Again a folder called A, and again webinar -1, whatever. So what I want to do is I want to write a table, and I want to write that table using this particular path. And that table writing over here basically means that my whatever this data frame is there will get saved in a comma separated. So over here SCP is basically separated, and this particular comma means a comma separated value file, which is basically nothing but a CSV. And if you also see, but this doesn't necessarily make a difference. So there is a point CSV I have given over here, sorry, dot CSV that I have given over here. So it will write a table, and this write table function, again, in case you want to see what exactly this is and how it works, you can go ahead and have a look at it later. I will not do that right now. Okay. So this is write table. What happened? Oh, sorry. I put two C's over here. I shouldn't do that. Their write table. So basically, write table will go ahead and write this particular data frame into a CSV. So that is what it will do. And we've got just about 2 more minutes for 9 o'clock. But if you guys are okay, yeah, it's almost 9 is okay. But I think I'll just go through this recording. So in case you guys want to stick around and have a look, you can. Otherwise, later on, you can see the recording. Either ways, I think I'll just go through the entire thing. Okay, so what will happen is this will write a table, and it's already done that. And how I know it's already done that? Because it's gone ahead and it's showing me the prompt again. If it doesn't show me the prompt, then I wouldn't know that it's done that. Okay, so I go to webinar 1 and I see over here that there is this 66 MB, sorry, 64.7 MB file which is there, which is a CSV file. I will not open this because then again displaying it could create challenges for my system's memory. I will not do that. Now going ahead and yeah, so this one I can straight away comment. I don't want to do this now because I already have downloaded that particular data from the internet. Now I want to see the dimensions of this particular data frame. So again, it shows me the same thing: 6,000 observations and 5,000 variables or features or columns, and the observations is rows again. Okay, so checking for features columns with few unique relative to other values within feature, near zero variance or high frequency of most common. So what I basically want to do is, wherever I think that the feature is sparse, or the data within a particular feature is sparse, I want to do away with that. I don't want to keep that particular feature. The reason I don't want to keep that feature is because when I go ahead and do any kind of analysis on data which is so much feature rich or has got so many features, usually called big data, um, we want to do feature reduction. A feature reduction is usually done with principal component analysis, but which is a statistical a methodology. And before we get into principal component analysis, we can also do feature reduction by going ahead and just removing whatever is sparse data over there. Fine. So we need another library over here, which is library caret. So we go ahead and load caret. It says loading required package lattice. It is also loading lattice, which is again a package which has dependencies for caret. And now I want to see the system time, because these are few things which will take some time to compute. So I want to go ahead and see the system time, and the system time is basically the wall clock time and other things which are there within that particular class called system time, and it will measure the time as to how much time it is required for processing the command that that we are executing, and I'm saving it in T. So this is what I'm doing, and once it is done, it will go ahead and print T. So let's wait and see how much time this takes. And I have some of my previous run of the script saved, and later on we can even compare. We can see as to how much time it took then and how much time it is taking now, and things to that effect. So that can be done. Okay, so wait, can't necessarily do anything else. And this is the challenge with R. So what basically happens is, let me again, okay, it took 30.21 seconds. Let me again show you something which is quite interesting. And over here, if I go ahead and one second, yeah. If I look at the history and my recent tabs, okay. Yeah, R data table. So here's a wonderful package called R data table. So R data table helps you to go ahead and take care of some of these large data frames, large data matrices, and all these things, and it will help you put some of these things into the hard disk of R and not necessarily in the memory. So the RAM obviously would be less on most of the systems that we'll be using. So this R data table is again something which you can get into later on at a later stage. So it took 30.21 seconds, fine, perfectly fine. So what exactly is the class of this? It's a data frame, great. Okay, near zero variation of it. Fine, so just this description of what near zero variation is. So we are looking at things which are not close to zero variance, and those are the ones that we want to keep with us, and rest of them, whichever have variance close to zero, we will do away with. So presume that in one particular column or in one particular feature, there are 6,000 observations, or all of those 6,000 observations are the observation 0, or the observation 1, or the observation 2, or say the observation 2 and 3. So there is not much of variance which is there. So because there is not much of variance, we will not necessarily get much information out of that particular feature. A feature extraction or feature reduction is done basis information. So within principal component analysis, again, it is information which is that we are seeking, and those are the principal components which give us the maximum information. So the ones which do not give us the maximum information are not principal components. So even though this what we are doing right now is non-statistical and is basically intuitive, but still the logic behind it is the same. Okay, so now let's say print paste. Okay, sorry. So now what we want to do is we want to look at the range within this feature underscore 0 variable data frame that we have, and we want to look at the percentage of unique within this. And when we print this, when we say print paste range and this thing, so this range will basically come out as text, and then whatever is the value that this particular function will throw will be pasted in front of that particular text this thing field range, and it will get printed out. So let's look at this. So it says the range, it says range twice because there are two values which are coming out of that, and one is 0.01666 goes on, and then the other is 8.6. So anybody can make out that this on the range the minimum side is 0.016, on the maximum side it is 8.6. But let's say again we wanted this explicitly mentioned to us. So the maximum is this, which is 8.6, and the minimum is this, which is 0.016. So again, just a comment to make it more explicit. Yeah. Okay. Now we want to again see as to what exactly is there within this data frame, which is feature underscore 0 variance. So we go ahead and print the head. So head is usually just the top 6 values will get printed because it's a huge thing. It says 5,000 observations, and it's a huge size. I don't necessarily want to view it and all that. So I just go ahead and say head. Okay. So this is what I get as head. Now, what is the structure? Further, just similar to summary, but it'll give you the variable type for the number of variables which are there. So it says 5,000 observations of 4 variables. So what is the first variable? It's a frequency ratio, and like you see over here, the first variable is frequency ratio, and it's a numeric variable. Next is also numeric. Then the other two are logical. Logical means a boolean, this thing, yes, no, true, false, right, wrong kind of input is there. And logical will sometimes come out as 0, 1 also. So or if it comes out as false and true, we usually want to convert it as 0, 1 before we start doing some processing on this particular kind of variable. Okay. Now again pasting together, what we want to know is column count prior removal. So what is the number of columns that we have within this particular big data set before we go ahead and remove some columns? So what we get is 5,000. Fine. So that 5,000 we had already seen earlier also. Over here BD rod, so it shows 5,000 observations and variables. Do not confuse this with the 5,000 observations that you can see over here in the second thing of 4 variables. Now see, this is a slight difference. What was there in the columns has been converted over here in the rows, right? So it is again I will not call it as rotation, but at a later stage when we get into trying to understand what PCA is and other things, then we'll see when there is a rotation of either a vector or a matrix which is happening, how that happens and why some of these things why a column would get into a row's place, or why a row would get into a column's place. So it is similar to what we do in Excel, like the transpose function in Excel, but slightly maybe at a more higher level, whichever way. So this is what we need to again look at. The same thing we could have also got. I'm removing this, it says uncomment over here. I'm removing this and I'm again running this. Similar output we could have got over here also. But because I am not given print, it is not printing on its own. When I click on this particular thing, so it goes ahead and prints. Now this code will not print. So if I were to remove everything and I were just to keep paste over here, it will not print, because it is showing me a plus sign. It is still looking for some input from my end, which I am not giving, so it will not do anything. So nothing will appear in the console. What I'll do is I'll just comment this again and let it be. Okay. So like I said, we count the number of columns oblique features in the raw big data. We remove features with less than 0.2% variance. We've not done that. We want to remove features with less than 0.2% variance. This is done by checking within vector percent unique. So within that particular data frame, there is a vector which is storing that value percent unique, which shows us this value. So if the percentage unique value is less than 0.2%, we drop the feature or the column. So this 0.2% is what we'd kind of picked up initially, but this is not what, there was not many features which were getting dropped. So what I did was I went ahead and looked at 0.5% also. So this is how I have done this. I have, what went wrong? Okay, yeah. Because of that particular, I never closed that, right? So within that paste, it has gone ahead and taken this as the continuation of that command, but it is not. So what I'll have to do is and now it is showing me the prompt over here. Earlier it was just showing me the plus, and I had gone ahead and executed this from the script. Now I'll again execute this and it should work. There. So it's showing me 4,478 observations out of those 4 variables. And initially what did we have? We had 5,000. So this 5,000 I'm comparing this to. So from 5,000 I've come down to 4,478. Let me still experiment and let me say I go in for 0.5% now. Now let's see what I'm left with. I'm left with 4,123. So subtracting 4,123 from 5,000, what do I get? This is what I get. So I get 877 features. So that is okay. So I stick around with 877 features and I execute this, which is my next command, which gives me from BD raw, I have got now BD underscore what was that? Something variation we are looking at. 1 second. Yeah. No zero variation. So things which are not close to zero variation have been retained, and features which were, which had variation close to zero have been removed. And how many features have been removed? That is 877 features have been removed. And what is left behind is this particular data frame from this. So from the raw big data, we've gone ahead and done feature reduction. This is what we've achieved. Now I think I'll stop over here and I'll probably continue at some other time. I see 6 attendees are still there and there are some questions which are there. No, there are no questions right now. Okay, so guys, there's 4 of you who are there as participants. I'll have to stop now. And why Why does it say mute also? Have I muted you guys or what? Can somebody speak? Did I mute you? I did not mute you intentionally. Kunjal? Is that Sirisha? Yeah, I can hear you, Sirisha. I'm extremely sorry. I think I muted you guys unintentionally. I did not do that on purpose. Okay, perfect. That's okay. So what I'll do is I'll stop right now and I'll continue this again because I'm not even halfway through my script. I'll just stop right now. And thanks a lot, all of you, and myself and Yusuf will upload this on the YouTube channel and we'll share it with you. And this entire script and code and everything, any which ways, I'll share it on that website blog that I have. Thanks a lot. Thank you so much. I hope you enjoyed it. Thanks. Bye. Murli, thanks a lot. Thanks for being there.